And let's go back and look at the data set again before we transform it into a transactions sparse matrix. Okay, so now everything's a factor or an ordered factor. And where we had, let's see, age, let's find age. Where we had age before, we don't have numbers anymore. We just have young, middle-aged, blah, blah, blah. And these numbers actually, 1 is young, 2 is middle-aged, 3 is whatever the next one was, senior, so forth. Let's pop it open. See, here's age. The numerics have just been replaced with the levels corresponding to the categorical range. Okay, but we're going to again coerce it into a transactions type sparse matrix. So we do that using as again. And let's take a look. If we try to express it so we can see what it looks like over here, we can no longer examine the whole thing. It just tells us. And you can use summary, however, with a sparse matrix. And summary, let's take a look at this. Will, first of all, give you the number, the dimensions, the number of rows and columns with a density, and I believe this means density, I'm not sure. In an incident matrix, it would just be the relative proportion of all the ones. But since we have some ordered factors, I'm not sure how it computes those, but most of them are binary variables where they're either 0 or 1, so this is a reflection of that somehow. And then it shows you the most frequently occurring items. And we had, let's see, we had a total of 48,000 and some odd records, and we note that, I see your question. Here, we have 48,842 records, and we see that of those 48,842, 46,560 had this value in the capital loss column. There was no capital loss. Question says, actually, I did mean the transactions command where you change 13 columns into 115. Yeah, not sure. I'd have to think about that. I don't know. It's a good point. Why do we have 115 columns? I believe it would be reflective of the different number of levels. I don't know. Send me an email. I'll try and figure it out before we meet next time. Next most, column 1, capital gain, none, most of the records. Then this one, remember what I was talking about? We had 15 columns. I think it's I read this. The 115 is a reflection of the different combinations of levels measured as binary variables. And so we had ordered categories for each one of those. If you had, say, four ordered categories, I think that would count as 4. It's somehow tied to that. What this means, if you add this up, these are frequencies, you'll get the total number of records. And there are 15 columns. 6 of them, or 9 records total, have at least 6 NAs for 1 column or more, for 6 columns. So it can't use the NAs. So there are 9 records where along the row there are 6 NAs. And there are 971 records where along the row there are 10 NAs. And there are this many records where along the row there are 4 NAs, and so forth. And then you have let's see, I'm not sure what this is. Could this be all of it? I don't know. This is explained in the exercise. I'd have to double check, but it's somehow reflective of the dispersion in the data, obviously. But I see. This measures the quantiles for this. Okay, so it's a measure of the distribution of these frequencies. There's the minimum, there's the maximum, so forth. Median and mean are very close because you have more up here, but it's biased towards this end. And then these are examples of extended information. It's not all of them, and I don't know what this last thing means. Okay, so it gives you summary information for your data set, but note it's qualitatively different from what you're used to seeing when you run the summary command. Okay, so so now we coerce it into an incidence matrix. Okay, and using as again, and let's just look at the first 2 rows of the incidence matrix. You see what I mean? So now we have this first 2 rows, and I bet you bottom dollar you have 115 columns in each of the 2 rows, because it's transformed all of those categories into zeros and ones, including the ordered categories where you had many categories in a column. So that's where the 115 comes from.